This section is on the applications of systems of linear equations. We will be talking about steps to solving applied problems, as well as solving geometry problems and money problems. First, when solving applied problems, there are steps that are helpful in doing so. For step 1, you want to read the problem and take note of what is given and what may be needed to be found. Step 2, you need to assign variables to represent any unknown values in the problem. After that, write a system of equations using the variable expressions. Once you have the system, solve the system of equations and state the answer to the problem and making sure you label it correctly. The last step is to check the answer in the system of equations to make sure your solution is correct. The first example is a geometry problem using two variables. It states, a rectangular basketball court has a width between 50 and 100 feet and a length between 100 and 130 feet. One particular basketball court has a perimeter of 320 feet. Its length measures 40 feet more than its width. What are the dimensions of the court? Step 1 says read the problem, and to find out what it's asking, we're asked to find the dimensions of the court. Next, we need to assign variables. Let's let L equal the length and W equal the width of the basketball court. After you have assigned your variables, we need to write a system of equations. Since the problem tells us that the perimeter is 320 feet, we can write one equation by using the formula for perimeter. We know that the perimeter of a rectangle is adding up all the sides, so we can say that 2L plus 2W equals 320. Write a second equation by using the fact that the length is 40 feet more than the width. So the length is 40 feet more than is represented by an addition sign, more than the width. These two equations will form our system of equations. Next, we need to solve. We could use the substitution method to substitute this W plus 40 in for L for the first equation. After solving for W, we find that W equals 60. Now, since we know that W equals 60, we can plug that back in to our equation L equals W plus 40 to solve for L. We find that the length is 100 feet. Next, we need to state the answer. Again, making sure that we label it correctly. So the length is 100 feet and the width we found was 60 feet. In order to check to make sure our solution is correct, we can plug both of these values back into the equation. Our first equation was 2L plus 2W equals 320. Our value for L was 100 and our value for W was 60. And when simplifying, we find that 320 equals 320 is a true statement, therefore this solution is correct. The next example is a money problem using two variables. It states, for a high school football game, 2 adult tickets and 1 child's ticket cost $10.50. One child's ticket cost $2.50. How much did one adult ticket cost? Well, to begin, what's helpful when reading these problems is to underline anything you think that might be relevant. We have 2 adult tickets and 1 child's ticket that cost $10.50. Then it also tells us that 1 child's ticket costs $2.50. It also states that they want us to find how much did 1 adult ticket cost. So to begin, we need to assign variables. We're going to let A equals an adult ticket and C equal a child's ticket. We can write a system of equations for the problem. It tells us that 2 adult tickets plus 1 child's ticket cost $10.50. That is our first equation. Next, the 1 child's ticket, represented by C, equals $2.50. By using the substitution method, we can plug in $2.50 for C in the first equation. After simplifying, we find that A equals $4. When you get down to this point, go back up to where you represented the variables. We see that A is an adult ticket. Therefore, one adult ticket is $4.